Welcome back to 3V Learning Center. In our last video, we covered VLANs, virtual local area networks, and how they split one physical network into separate, isolated segments. But here's the question I left you with at the end. If VLANs are designed to isolate traffic from each other, how do different VLANs ever communicate when they need to? The answer is Inter-VLAN Routing, and that is exactly what we are covering today. By the end of this video, you will understand what Inter-VLAN Routing is, the two main ways it is done using a traditional router versus a Layer 3 switch, and why it matters for network security and design. If you have not watched episode 1 yet, the link is in the description. Go watch that first. This video builds directly on it. Let us get into it. Let us go back to our example from episode 1. A university has 3 VLANs. VLAN 10 for human resources, VLAN 20 for finance, VLAN 30 for IT. These VLANs are isolated. A device on VLAN 10 cannot directly reach a device on VLAN 20. That is exactly what we wanted for security. But here is real life. Sometimes departments do need to talk to each other. The HR manager needs to send a payroll file to finance. The IT team needs to manage servers that sit on a different VLAN. A student portal on VLAN 40 needs to pull data from a database on VLAN 50. If VLANs are completely sealed off from each other, none of that is possible. So we have a problem. We need isolation for security, but we also need controlled communication between VLANs when it is legitimate and authorized. The solution is Inter-VLAN routing. A router or a Layer 3 switch that sits above the VLANs, acts as a controlled gateway, and decides which traffic is allowed to cross between them. Think of it like a border crossing between two countries. You cannot just walk through the wall. You go through the official checkpoint, you show your credentials, and the officer decides whether you can pass. Inter-VLAN routing is the process of forwarding network traffic from one VLAN to another using a Layer 3 device, a device that can read IP addresses, not just VLAN tags. Here is the key principle to understand. A regular switch operates at Layer 2 of the network model. It reads MAC addresses and VLAN tags. It cannot route traffic between VLANs on its own. A router or a Layer 3 switch operates at Layer 3. It reads IP addresses. It can receive a packet from VLAN 10, look at its destination IP address, and decide to forward it to VLAN 20. So the traffic flow for inter-VLAN communication looks like this. A device on VLAN 10 sends a packet. The packet travels to the switch. The switch sends it up to the router via a trunk port. The router reads the destination IP, decides it belongs on VLAN 20, and sends it back down. The switch delivers it to the VLAN 20 device. The router is the gatekeeper. You configure rules on the router to control exactly which VLANs can send traffic to each other, on which ports, and under what conditions. This is why inter-VLAN routing is so important for security. Isolation is the default, and communication is explicitly permitted. There are two main ways to do inter-VLAN routing. Let us start with the first one, router on a stick. This is the classic method. You have one physical router connected to your switch using a single trunk link. That one physical link carries all VLAN traffic. But here's the clever part. On the router, you create what are called sub-interfaces, virtual interfaces, each assigned to a specific VLAN. So your single physical router port might be divided into 3 logical sub-interfaces. Sub-interface 1, assigned to VLAN 10, given the IP address 192.168.10.1. Subinterface 2, assigned to VLAN 20, given the IP address 192.168.20.1. Subinterface 3, assigned to VLAN 30, given the IP address 192.168.30.11. Each of these subinterfaces acts as the default gateway for devices on that VLAN. When a device on VLAN 10 needs to reach VLAN 20, it sends the packet to its gateway 192.168.10.1, which is the router subinterface. The router receives it, looks at the destination IP, and routes it out through the VLAN 20 subinterface. Here is why it is called router on a stick. There is one router connected by one trunk link, handling multiple VLANs, like a single stick holding everything up. The advantage of this method is simplicity and low cost. You only need one router port and one cable. The disadvantage is that all inter-VLAN traffic flows through that one physical link, which can become a bottleneck on busy networks. You do not need to memorize these commands today, but I want to show you what router on a stick configuration actually looks like so it is not a mystery. On a Cisco router, you would create sub-interfaces like this. You start with the physical interface, let us call it Gigabit Ethernet, 0 1 source and 0. You bring it up with no shutdown, then you create the first sub-interface. Interface Gigabit Ethernet 00010. You tell it this sub-interface handles VLAN 10 traffic using the command encapsulation .1q10. Then, you assign its IP address 192.168.10.1 with a subnet mask. You repeat this for each VLAN. Each sub-interface gets its own VLAN number, its own IP address, and its own encapsulation command. The encapsulation .1q command is where the 802.1q tagging standard we covered in episode 1 comes in. The router uses this to identify which tagged VLAN each packet belongs to. On the switch side, the port connecting to the router must be configured as a trunk port carrying all VLANs. That is it. Straightforward, and it works well for smaller networks or lab environments. For your Network Plus or CCNA studies, understanding this configuration is essential. Now let us talk about the second and more modern method, the Layer 3 switch, also called a multi-layer switch. Remember how we said a regular switch operates at Layer 2 and cannot route between VLANs? A Layer 3 switch breaks that rule. It can do both. A Layer 3 switch is essentially a switch with routing capability built directly into the hardware. It can forward traffic at wire speed the same way a normal switch does, but it can also look at IP addresses and route between VLANs, without needing an external router. Instead of sub-interfaces like we saw in Router on a Stick, a Layer 3 switch uses what are called Switched Virtual Interfaces or SVIs. Each SVI is a virtual interface assigned to a VLAN, with an IP address, acting as the default gateway for that VLAN. The configuration looks like this. On the Layer 3 switch, you create an SVI for VLAN 10 interface VLAN 10, IP address 192.168.10.1. Same for VLAN 20, same for VLAN 30. You then enable IP routing on the switch with the command IP routing, and that is it. No external router needed for basic Inter-VLAN routing. Now how does a Layer 3 switch compare to Router on a Stick? Layer 3 switches are faster because routing happens in hardware, not software. They reduce the bottleneck problem because there is no single uplink to an external router. They are cleaner to manage one device instead of two. The downside? They cost more than a basic switch, and they may have fewer advanced routing features than a dedicated enterprise router. In most modern enterprise networks, you will see Layer 3 switches handling Inter-VLAN routing inside the building, with a dedicated router handling traffic going out to the internet. Let us put these two methods side by side so the differences are crystal clear. Hardware required. Router on a Stick needs a switch plus a separate external router. A Layer 3 switch is one device, it does both. Performance. Router on a Stick routes in software via the router CPU fine, for small networks, but slower under heavy load. A Layer 3 switch routes in hardware much faster at scale. Bottleneck risk. Router on a Stick has a single trunk uplink which can get congested. Layer 3 switches do not have. This problem routing is distributed across the internal fabric. Cost. Router on a Stick is cheaper up front, you can use a basic router. A Layer 3 switch costs more, but reduces complexity. Best used for. Router on a Stick is ideal for small offices, labs, and certification study environments. Layer 3 switches are standard in enterprise, campus, and data center environments. For your exams, Router on a Stick is heavily tested in Network Plus and CCNA. Layer 3 switching comes up in CCNA and beyond. Know both. Here is something that does not get enough attention in beginner courses. Inter-VLAN routing is not just a connectivity topic, it is a security topic. Remember, the whole point of VLANs is isolation. When you add inter-VLAN routing, you are deliberately creating pathways between isolated segments. That means you need to be very careful about what you allow through. The tool for controlling this is an Access Control List, or ACL. An ACL is a set of rules configured on the router or Layer 3 switch that determines which traffic is permitted or denied between VLANs. For example, you might allow VLAN 10, HR, to send email to VLAN 20, Finance, but deny VLAN 10 from accessing VLAN 30, IT servers. You might allow VLAN 30 to reach all other VLANs, because your IT team needs management access, but you block everything from VLAN 20 reaching VLAN 30. Without ACLs on your inter-VLAN routing configuration, you have created a router that lets everything through, and that defeats the security benefit of VLANs entirely. The golden rule, inter-VLAN routing should use a default deny approach. block everything, and then explicitly permit only what is needed. In a security plus context, this is called the principle of least privilege applied to network routing. Only grant the minimum access required. We will do a dedicated video on ACLs, but just know that whenever you configure Inter-VLAN routing, ACLs should be part of the conversation. Let us zoom out and see how everything we have covered fits into a real enterprise network. At the top, you have the internet and an edge router that connects the organization to the outside world. This router handles traffic going in and out of the building. Below that, in the core of the network, you typically have a layer 3 switch, or a pair of them for redundancy. This is where inter-VLAN routing happens internally. It routes traffic between your VLANs at high speed. Below the core, you have access layer switches, the ones end devices plug into. These are your standard layer 2 switches, with ports configured as access ports for each VLAN. So the traffic flow for a device on VLAN 10 talking to a device on VLAN 20 looks like this. The VLAN 10 device sends to its default gateway on the layer 3 core switch. The core switch routes the packet to VLAN 20. The access switch delivers it. Traffic going out to the internet goes VLAN device, access switch, core, layer 3 switch, edge router, internet. This 3-tier model core, distribution, access is the standard design in most enterprise, university, and government networks. At a university like Makawan, this would mean student VLANs, staff VLANs, research VLANs, and guest Wi-Fi VLANs, all isolated from each other, all connected through a tightly controlled layer 3 core, with ACLs enforcing what can talk to what. That is a real production-grade network design, and you now understand how it works. Time for a quick knowledge check. 3 questions. Pause after each one if you need a moment. Question 1. Which of the following best describes router on a stick? A. A router with multiple physical interfaces, one per VLAN. B. A single router port with sub-interfaces handling multiple VLANs via a trunk link. C. A layer 3 switch with built-in routing. D. A firewall between 2 VLANs. The answer is B. Router on a stick uses one physical port on the router with logical sub-interfaces, each tagged for a different VLAN, connected via a trunk link to the switch. Question 2. What is an SVI in the context of a layer 3 switch? A. A security vulnerability index. B. A sub-interface on an external router. C. A switched virtual interface. A virtual interface assigned to a VLAN acting as its default gateway. D. A type of VLAN tag. The answer is C. SVI stands for Switched Virtual Interface. It is the layer 3 switch equivalent of a router sub-interface. It gives each VLAN a gateway IP address for inter-VLAN routing. Question 3. Why should ACLs always accompany inter-VLAN routing configuration? A. ACLs speed up the routing process. B. Without ACLs, inter-VLAN routing allows all traffic between all VLANs, removing the security benefit of VLAN isolation. C. ACLs are required by the 802.1q standard. D. ACLs assign IP addresses to VLANs. The answer is B. Without ACLs, a router or layer 3 switch will allow all traffic between VLANs freely, which defeats the purpose of VLAN isolation. ACLs enforce the principle of least privilege. Let us bring it all together. 6 things to take away from this video. 1. Inter-VLAN routing is the process of forwarding traffic between VLANs using a layer 3 device, a router or a layer 3 switch. 2. VLANs do not communicate by default. Isolation is the default state. Communication requires explicit configuration. 3. Router on a stick uses one router connected to a switch via a trunk link with sub-interfaces for each VLAN. Simple and low cost, but can bottleneck on large networks. 4. A layer 3 switch performs inter-VLAN routing in hardware using switched virtual interfaces SVIs. Faster, more scalable, standard in enterprise networks. 5. ACLs must accompany inter-VLAN routing to enforce the principle of least privilege and prevent unauthorized cross-VLAN communication. 6. In a real enterprise network, layer 3 switches handle internal inter-VLAN routing, while an edge router handles external internet traffic, a 3-tier architecture. If you can explain all 6 of those points, you understand inter-VLAN routing at a level that will serve you well in your studies and your career. And that is Inter-VLAN routing. If this video helped you, please hit the like button. It takes 2 seconds, and it genuinely helps this content reach more people who are trying to build their networking knowledge. Subscribe to 3V Learning Center so you get episode 3 when it drops. And, in episode 3, we are going deep on access control lists, what they are, how they are structured, permit and deny rules, standard versus extended ACLs, and how they protect your inter-VLAN routing configuration. Drop your questions in the comments if something was not clear, ask me there and I will help. Study resources and a link to episode 1 are in the description below. Keep learning, keep building, see you in the next one.